We've now completed the next step, which was to make some changes to our state table. This change needs to be made not just to the FMEA state table, but also the design. So I do want to make that very clear. You don't just change the FMEA. The design also has to be changed so that the software engineers can code to the new design. In this step, we also analyze the mitigations and the tests to be identified. We also have a new root cause here, which is a prohibited state transition, which I'll show you shortly. Okay, so let's look at our new state table. You can see we now have a faulted state. There used to be 25 transitions. Now there's 36 transitions. And one of them is prohibited under all cases. So prohibited transitions can be either marked with a blank cell or with an X, either one. And so we can see the transition from fault to emergency is prohibited. It's just the way the system engineers want it to work. And all the other transitions are conditional. So in our list now, we should have 35 conditional prohibited transitions and one transition that's prohibited all of the time. So we'll go take a look at that. Let's look at our effects. We'll go look at that real quick and see the rows that were added. Go to TLSM. All right. So you can see now we do have that new TLSM1 row, which wasn't there before, which is the transition from fault to emergency is allowed. And you can see we have the effect identified there. Unfortunately, there's good reason why it's prohibited. It does lead to erratic behavior. And now we have, instead of having 25 rows for TLSM2, which is a conditionally prohibited transition, we have 35 rows. You can see for each cell that was in the table. So we have a few more. We now have another TLSM3 row for the fault state. It can get stuck in fault. It can also, we can have a power loss while in the fault state. So another TLSM4 row was added. You can see right here. And there could be another user abort in the fault state. Now it turns out there's not really a way for the user to abort the thermostat. It just doesn't really work that way. So these are actually not applicable, but you can see it did add the row for it in case it is. All right, so let's look. The likelihood section is already filled out. And let this update. The software is updating it. You can see that existing controls were entered in here. So we have, these are actually proposed controls. It's also possible to override. These likelihoods are computed by the software. So the existence likelihood is how likely it is the problem exists, period. That's based on the questions that you answered. Manifestation is whether it's a single point, multiple point, or a triple point failure. This one happens to be a double fault failure, which means that the user has to enter in something invalid and the software fails to check it. Controls here, we got a 10 here, which is the worst risk because we don't have any. Detectability is kind of a middle score there, how likely somebody is to actually test this based on the questions that we answered for testing, and you can see our overall RPN. So in this case, the likelihood is averaged across these four areas. You can see the likelihood is 6.4375, which is relatively high. It's above average. When we multiply that by the severity, we get the RPN of 45. Now you can overwrite these, but you do need to justify why you did overwrite them. We can also identify some compensating provisions. For most of these root causes, there really aren't any compensating provisions. Compensating provision means something that the user can do to prevent the failure. The user is almost never going to be near the thermostat, so most of the time there's not a compensating provision. The only time there might be is if a faulty condition was transmitted and they receive it through their cell phone app, through the Wi-Fi. They might be able to do something, but again, they could be out of town, so in many cases it can't be easily compensated for. We also have a Mil Standard 882E control category. This thermostat is not it's not a Mil Standard 882E type weapon, but we do have it. If you select the control category, it will automatically fill in this wiki. All right, so in the next step, we're going to look at the mitigations now that we've defined the likelihood and that we've updated the design.